Hello everyone, today we're going to present to you some basic trigonometry concepts that you're going to need at MSP, and this is what we will run you through. First, we're going to look over the Pythagorean triangle, then we will show you the trigonometric circle and how the Pythagorean triangle relates to it. We're going to show you a table of basic trigonometry values that is going to be really useful. Then we'll talk about the difference between degrees and gradients and how they're both used. And finally, we'll give you an overview of everything with a circle and its function.
The first trig concepts we're going to look at have to do with this right angle triangle. So as we may have seen before in high school, we know that sine of alpha, this angle here, will be the opposite over the hypotenuse. Cos of alpha will be the adjacent over the hypotenuse. And tan of alpha will be the opposite over the adjacent. And a nice little way to memorize this is just think of this nonsense word, SOHCAHTOA. So this is just a trick to memorize it. And another very important thing to remember is if you want to calculate the actual value of your angle alpha, for example, if you're using sine, you have to use arcsine, which is going to mean that you use this notation over here, and then here you put your values of the opposite and the hypotenuse, and this way you can actually get your angle, because this value over here is going to be different from the value of only your angle alpha. So yeah, and this also applies to cos alpha and tan alpha, so the notation will just go like this. And this way you would be able to find the value of your angles, but we will show you how to do this with exercises in another video. The next three concepts we're going to look at have to do with this circle over here, and the really cool thing to know about the circle is that its radius all around is going to be equal to 1, and its middle point here is going to be 0. And as you can see, it's divided into 4 different parts called quadrants, and they have different properties in the coordinates of the points along the circumference, and I'm going to show it to you now. So imagine you have a point over here, and you can imagine this as a projection like this, and this as your angle alpha. The coordinates of that point over here will be equal to cos of alpha sine of alpha. So cos of alpha will be like your x, while sine of alpha will be like your y. And since we are in the first quadrant here, we know that cos alpha and sin alpha, x and y, are going to be positive. So I'm going to fill this table over here. And we know that tan of alpha is equal to sine over cos, and since both cos and sine are positive, then your tan is just going to be positive again. And these properties change from quadrant to quadrant. For example, if you have a projection here, like this, and your angle always has to start here, so your angle would go like this. Your value of x is actually going to be negative this time around because you're on this side, but your value of y will still be positive, so sine will be positive. And then taking both into consideration, tangent is going to be negative. And I'm just going to fill the other parts of the board now. So there's a very important formula to keep in mind with this circle that has to do with the Pythagoras theorem from the right angle triangle that we looked at in the beginning of the video. So if we have a triangle over here, I'm just going to draw it this side to make it more clear that it's a right angle triangle here. And the Pythagoras theorem states that the hypotenuse squared is always equal to the opposite side squared plus the adjacent side squared. And this can also be applied here, but with the concepts that we learned from the circle. So we know that our hypotenuse, this side over here, is always going to be equal to 1. So I'm just going to replace that. Okay. And then we know that this side down here is going to be equal to our cos of the angle. So like this. And this one, the y, is just going to be the sine. So this is just an adaptation on the circle of the Pythagoras theorem, and it's helpful when doing trig calculations.
Okay, so as we said before, we know that pi radian is going to equal to 180 degrees, and that's basically also going to mean that then 30 degrees is going to equal pi over 6, 45 degrees is going to equal to pi over 4, and 60 degrees is going to equal to pi over 3. And this is a really neat trick to fill in this table. You just have to go 1, 2, 3 on the sin squares and then the opposite for the cos, and you will just square all those values and then put them over 2. Then of course if you have the square root of 1, that's just going to equal to 1. So let's just change that. And then in the end, you know that tan is equal to sin over cos. So you just need to take the values and make that calculation. So sin over cos also means that you can do this multiplication and you just switch the numbers around. You do that for all of them. And then you proceed with these calculations. And you can get your tan values. And that's just really an easy way to fill up this table, which you can also find in the cheat sheet if you need to refer back to. It's important to remember that the angle can be expressed in radians as well as degrees, and what a radian is a pure measure based on the radius of the circle, as shown on this little clip. It's also important to know that in half a circle, there are actually pi radians, which corresponds to 180 degrees. And that means that 90 degrees, a quarter of the circle, equals to pi over 2 radians, and that an entire circle, 360 degrees, equals to 2 pi radians. To finalize, we would just like to show you this really useful tool that really illustrates all the concepts that we have talked about. As you can see, when you move your mouse along the circle, you can see the sine and cosine changing as well as the tangent, and it really helps you visualize all these things as well as how they're represented in trigonometric functions on the right side. You can also use these tools down here to look at degrees or radians. And yeah, we highly recommend using this website and the other resources we have included in the description if you still have difficulties understanding these trigonometric concepts.